everyone. We are talking about polar coordinates today. So polar coordinates are just another way of navigating a Cartesian plane, right? So what we've done, like for all your other math classes ever, is we've done what are called rectangular coordinates. And rectangular coordinates are kind of what they sound like. I think about it as like driving downtown, where if I want to get to a point, I go a certain distance to the right, I go a certain distance up maybe, and then I get to my point. So in the process, I kind of make a rectangle. Or if I want to go down here, then I go to the left, I go down, and I get to my point. Okay, so I have an X and I have a Y, and that tells me how far to go laterally and how far to go vertically, and that's how I get to where I want to be. Okay, with polar coordinates, slightly different. Okay, so with rectangular coordinates, I started from the origin. With polar coordinates, I'm starting from what's called the pole. Okay, so that's my center. Okay, and with polar coordinates, if I want to get to a spot, I first of all have to figure out the angle to that spot, and then I also have to figure out my distance. So I have to figure out how far this is, which we usually call r. All right, and this is what we call polar. Or for instance, if I want to go down here, again, I have to figure out my angle to get there, so this whole thing, and then I have to figure out this distance from the pole, or from what we used to call the origin, now in polar is called the pole. So from the pole to whatever point I'm trying to reach, I have to figure out that distance, which we call r. And so with polar coordinates, instead of an x and a y, I have an r and a theta. Those are my variables that I use. Now they're essentially the same as x and y, but they tell me different things. A theta tells me my angle, and r tells me my distance. So that's what we're going to put here. So we usually go r theta, and that's what actually goes in this box here. So P has polar coordinates r and theta, where r is my radius or my distance, and theta is my angle. That's a really bad one. Let me try that again. Where theta is my angle. All right, so we got to go way back to the beginning of the semester when we first talked about graphing angles. We're going to practice plotting these polar coordinates. Okay, so remember, my first number is r, which is my distance. My second number is theta, which is my angle. And it's kind of obvious here because we're in radians. So here, first of all, I need to figure out just where my angle is. So 5 pi over 3, if you remember, this is pi over 2, this is pi, this is 3 pi over 2, and then this is 0 over 2 pi. 5 pi over 3 is just less than 2 pi, and it's bigger than 3 pi over 2. Okay, again, remember, if this kind of freaks you out, just ignore the pi for a second, so I have 5/3. 5/3 is less than 2. 5/3 is also bigger than 1.5. All right, so it's going to be over here somewhere. And typically, when you're graphing polar coordinates, you're going to have special graph paper that's different from the coordinate paper that you've seen before. It has a bunch of circles on it. For now, we'll just make do. So first of all, I have to figure out my angle. So I figured out my angle here, which is 5 pi over 3. And then we're going to have units along this line. And I have to go out 3 units. So 1, 2, 3. And that's my r value is 3. And so from that, I figured out that this is where I want to be. Okay, now it's the same thing on the next example, except this time I have a negative radius. And if you remember from a long time ago, negative radius, if I have a negative r, that means you go backwards. All right, so again, first thing I have to do is figure out what my angle is, or where my angle is. It's pi over 4, which is in the first quadrant. It's 45-degree angle. Hey, well, normally I would go out 2 units and give me my point. But because I have a negative r value, I have to go backwards 2 units. That's where my point will lie. Okay, that is plotting polar coordinates. All right, let's convert. So let's practice converting from polar to rectangular. Okay, so there's 2 really important equations for you to remember. We're going to use them all the time. We're going to use them next year too. So x equals r cosine of theta. Y equals r sine of theta. Okay, so if you remember from last semester, x always went with cosine and y always went with sine because of the unit circle. And so x was always your adjacent and y was always your opposite. So that's why x always went with cosine and y always went with sine. So it's the same thing here. It doesn't change, except now they both have an r attached to them. Okay, so if we wanted to convert 6 comma pi over 6 from polar to rectangular, we just need to use these two formulas and literally just plug in. So I need to solve for x. X is going to be r. So remember, your first number is r. Your second number is theta. Okay, and if you don't remember unit circle, we can go over the hand trig stuff in class, but cosine of pi over 6 is the square root of 3 over 2, which simplifies to 3 root 3. Okay, on the other hand, I have y, which is r sine of theta, so 6 sine of pi over 6, and really your numbers should stay the same when you're doing this every time. So this time I have 6 times sine of pi over 6, which is 1/2, which is just 3. So my rectangular coordinates will be 3 root 3, comma 3. Okay, and I mean, that makes sense. So let's just kind of check our answer here. That makes sense. So if I think about where this is going to be on my graph, pi over 6 is right here. And then I have a positive radius, so I just go out 6, 2, 3, 4, 5, 6. So I'm out here. Okay, so that's where my point is. Now, if I think about what I got from my answer, 3 root 3 is going to be somewhere out here. 3, I have to go 3 units up, so I go right and then up, and I'm in the same place. So I'm at least in the same quadrant. Right, so my answer makes sense, it checks out, so I'm happy. Okay, now converting the other way, there are more equations that are going to be really important for you to memorize. And luckily, you've seen them both before. So the first one is r squared equals x squared plus y squared. Hopefully you have seen this before. This is literally the Pythagorean theorem. Literally. My second equation is tangent of theta equals y over x. And now we have seen this before. Remember, tangent is the same thing as sine over cosine, so y over x, or tangent is opposite over adjacent, so y over x. Okay, same thing. Okay, so what this means is that my r value is going to be either plus or minus the square root of x squared plus y squared. And this means that theta is going to be arctangent or inverse tangent of y over x. Okay, so I mean, you'll notice, but the fact that there's a plus or minus here means that there might be multiple answers. And if you remember with arctangent, sometimes you can get multiple answers with that as well. So yes, there will be multiple correct answers when you're converting from rectangular to polar. And it's kind of up to you to figure out which one's right and which ones are going to be wrong. Now, what you can do is just ignore the plus or minus. So because this is a distance, you can ignore this plus or minus here and you can get a right answer every time. It's just that there will be multiple right answers. And because it's a distance, we can go ahead and ignore the plus or minus if you want. So right here, I'm converting -1, negative root 3 from rectangular to polar. Something that I typically do is just kind of get an idea of what I expect from my answer. So if I convert -1, negative 3 to from rectangular to polar, well, first let's just graph this. So -1 would be about here, negative root 3 would be about here. So I'm expecting something in the third quadrant. Expecting something in the third quadrant. All right, so now let's just plug these values into my equations. Remember, this is x and this is y now because we're in rectangular. I need to solve for r. So the square root of -1 squared plus negative root 3 squared. Okay, well, let's reduce this. So -1 squared is 1. The square root of 3 squared is 3. So I get the square root of 4, which is 2. Okay, so that's my radius. Now, when I'm solving for theta, it's arctangent of y over x. So in this case, negative root 3 over -1, which is just arctangent of square root of 3. Okay, now if you don't remember your trig tables, that's okay for now, but you are going to need to be able to calculate this. So this is going to be pi over 3, and then there's always going to be another answer for arctangent in the opposite quadrant. So pi over 3 is here. The opposite quadrant is the third quadrant, so 4 pi over 3. Hey, now with the number that I got here and with the angles that I got, now I have to pick which one makes sense. And so if I think about the fact that my rectangular coordinates were in the third quadrant, it probably makes sense to pick the angle that's also in the third quadrant. Okay, so my answer will end up being 2 and then 4 pi over 3. That's what would make sense here. Now, if you consider the plus or minus in this pi over 3, you could get another answer. Right, so if you go to pi over 3 in the first quadrant and then go backwards 2, like we did in that previous example, that would get you to the exact same place. So there are multiple ways to get to the same point. So like I said, there will be multiple correct answers. However, if you just consider the positive radius, you will always be able to get to a correct answer. Okay, so you don't have to worry about this. You just worry about literally just picking the one angle that makes sense. Okay, so it helps to have an idea in mind of where your quadrant's going to be. Okay, and last problem, we want to convert this equation from rectangular coordinates to polar coordinates. What we mean by that is I have xy, I want to go to r theta. Okay, so I want an r and a theta in my equation. Well, I know that x equals r cosine, and I know that y equals r sine. So given that 4xy equals 9, I can just substitute. So I can take both of these and plug them in. So x is the same thing as r cosine of theta. Y is the same thing as r sine of theta. And we can simplify this a little bit. So I have r squared, I have sine times cosine. And you could simplify this even more. I'm not expecting you to remember this, but we do have a double angle that we could use here. So we could reduce this even further. But again, I'm not expecting you to get to this step. So if you get to this step, I'm happy. That's fine with me. Okay, well, that's it for this video. I will see y'all later.